Hey, good morning, everybody. We are going to talk about angles. What's your angle? Pretty exciting stuff. A lot of vocabulary. If you can take the vocabulary word and associate it with 180 degrees or 90 degrees, life is good. All right, we'll start off with a quick little warm up. 10x plus 4x minus our good friend. Oh, there's no minus. Um, just some algebra. So what I'll do here is take you one step at a time. Um, the parentheses, they don't affect us. They say, hey, this came from somewhere. Do everything in the parentheses. Once you're done with the parentheses, you can't do any more. You just drop them. So we're going to combine like terms right here to here. So we have 10x and 4x. That's where we get the 14x. Uh, the um, The -5 and the +3 give us a -2. I'm going to add 2 to both sides, so I get 182, and then I'm going to divide by 14. So I'm hoping at this stage you're getting better with your algebra. You're not scared of it. Right now, I would certainly like you to try this one. We'll pause it for a second. Okay, we're back. And hopefully you combine the like terms, get 3x plus 3, subtract 3 from both sides, and divide by 3, and we get 29. All right, moving on. Hey, just once again, throwing little facts out there. Some stick, some don't. The three angles of any triangle add up to 180 degrees, always. Obtuse triangles, acute triangles, scaling triangles, isosceles triangles, every kind of triangle you want, they will always add up to 180. So when we set up the equations, we set up all three added up, set it equal to 180, and solve for R, or solve for W. A couple quick examples there for you. All right, what is today all about? It's can you measure an angle and can you classify an angle? So measuring is using a protractor. So we will use a protractor. And of course, you don't have one at home, maybe, but you have one virtually. And then classifying is the characteristics. So it allows us to say it's an acute, obtuse. What you need to be able to do is if you read those words, understand what you're working with. So that's our goal. All right, first of all, what the heck? A How do you use a protractor? All right, well, let's just do an example. We want to measure the angle AOB. So first of all, we have to find AOB. The way we do that is we find A first, and then we look for O. Oh, there it is. And then we look for B. There it is. So order is extremely important. The middle letter is always where the sharp point is, called the vertex, okay? So hopefully you can see now our eyes are on that angle. So how we measure that angle with a protractor is we start with this kind of this base level, and then we move up from that. And most protractors can be read left to right, right to left. You have to be careful about which scale to read, which scale to read. So are we going, is our angle going 180, 170, 160, or is it starting at 0, because this is the base, and going up to 10, 20, 30, and right in the middle of 30 and 35, so that is going to be a 35-degree angle. Okay, cuts it right in half. Not too tough. I don't see, once you have your hands on this, it makes it a little bit better. So let's try another one. Let's try AOC. So here we go, AOC. That means we are measuring this angle right here. We start with the inner one, go up, it looks like 65 degrees. So AOC is 65 degrees. BOC, BOC. Now BOC is interesting because we are measuring this angle right here. So here we are at 35 and here we are at 65. So you guessed it. What is the angle between those two, just subtract those. So 65 minus 35 is equal to 30 degrees. Not too tough. This is all about, can you see all the possible angles? Um, for a situation, we're going to get a lot of situations that look like this. And I want you to know, it looks like one angle, maybe two angles, but there's actually three angles. The blue one, the red one, and then all of them put together, the purple one, I guess. So, going fast. All right, how do you name an angle? Well, you can name it Paul or Timmy or Sarah, whatever you want. But when we have notation like this, it's really important to name it correctly. Now, the easiest one I think is just say angle Y. And you can do that in this case because there's no other angles that you can confuse it with. There is only one angle right there, and it is Y. Sometimes inside the angle is a number, and we just name it with that, how that's labeled. Now, most of the time we're going to use three letters. It doesn't matter the order of the three letters as long as the middle letter is the vertex, is the sharp point. All right. So if you wouldn't mind, if you could give me two names. Oh no, let's not do two. Let's do three at least. Three names. All right, give it a shot. And we're back. So I would expect maybe F, E, D, maybe D, E, F, maybe angle E, maybe angle 2. So there's four possibilities in that case. All right, so this is where you pause it, maybe a quick sketch, write it down, but maybe you know this already. An acute angle is any angle that is between 0 and 90 degrees. Well, what's a 90-degree angle? Let's make sure this is probably our favorite angle. 90 degrees, right angle. All right, so when it's less than that, it's called an acute angle, and when it's greater than that, it's called an obtuse angle. If we keep going on this and we keep it flat, we get what we call a straight angle. This is the weirdest angle in the world. Most people don't see it because it's just laying there flat. There's no angle to it, but it is an important thing, and we're going to use the word straight angle a lot. So understand, if I had a couple letters here, B and C, we would say the measure of angle BAC is equal to 180 degrees. So this M out front means I want to know the actual measurement of that angle. Remember, this is just a physical object. That's just an angle. Okay. All right, JHM, and just last one here. If I have this angle right here, JHM, so I'm looking at this angle. Once again, the flat part is on this side, so I'm going to start on this, and it's increasing as I go, so I'll stay with the inner numbers, and it takes me all the way to 140, and then halfway to 50, so that is 145 as written. All right, why don't you try this one? Oops. Okay, I already gave it to you. MHK, MHK. You can do that a couple different ways. As long as you're consistent, you can go from the left or the right. Maybe we'll go this way this time. So there, I see that's at 35. And if we continue on to here, we get 125. So 35 to 125. Just find the difference between those two. We subtract it and we get 90 degrees. Oh, that's pretty cool. That is a 90-degree angle. All right. Yep, we don't need another example. All right, the angle addition postulate, just much like the segment addition postulate, where we take one little piece of the segment plus another little piece of the segment equals the whole segment. Ta-da! Well, the same thing happens here. We just add this angle plus this angle equals this angle. It's that easy. Angle addition postulate. Remember, the word postulate means we're not going to prove that this works. We're going to just say from our common sense that if we add this little plus a little, we get the big. There's the book notation if you want to pause it and get the RST, RSP, and the PST look to it, you can. I think mine worked just fine also. So here is a particular example of a problem. There are two angles here. There's this angle and there's this angle. Given that LKN, so take your time and read and find the letters, find the angle that they're talking about. Where is LKN? Where is LKN? Well, let's find it. Here's L, here's K, and here's N. So they're saying the whole thing is equal to 145 degrees. Okay, so the angle addition postulate says if we take this little one plus this little one, it should equal the big one. And that's what I've written here. This is just kind of a cool statement. It says you know what you're talking about. You want to be thorough. And there's some days we want to be thorough and some days we kind of want to hustle through it. There was the little plus the little equals the big. And then we're off to the races as far as just algebra. That's why I'm doing those warm-ups, because I've had students get here and then they're handcuffed with the algebra. It's a bummer. So I'm going to combine like terms. The 2 and the 4 give me 6. The 10 minus 3 is 7. I'm going to subtract 7 from both sides, and I'm divide by 6. So subtract 7 and divide by 6. So this is the best wrong answer because it's not what they ask. They ask for find the measure of those two little angles. They want the measure. So what I do is I plug it into the 2x, LKM is 2x plus 10. So now I know what x is, plug it in, and I get 56. I do that for the second angle. MKN, I know it's 4x minus 3, plug in the x, multiply, and I get 89. If I add these two together, I get 145. Hey, that's a great way to check your work. Great way to check your work. All right, so this is where the vocabulary comes into play. It's pretty darn obvious that this is the little angle, this is the little angle, and this is the big angle. Please associate a straight line with 180 degrees. It is called a straight angle, so we want to think about that being 180 degrees. This should look familiar. This plus this equals this. That was our warm-up. So we've already solved that for x, so you can go back and check that. What's another situation? What if the angle is a right angle? Let's just get rid of that. Well, in a right angle, we need to associate with 90 degrees. So little plus little is equal to big. And that should also look familiar. That is also the warm-up from earlier. So we solved that for x, life would be good. Just to remind you, we already did that. Those are the two problems. So you can see that we practice this so that when we get into the heat of the battle, a little bit more contextual, we have the skills to do it. So another vocabulary word that you need to understand, bisect. It's not intersect. Intersect just means, whoa, boom, you know, whoa, they touch. Bisect means it cuts it exactly in half. So when we get a situation that doesn't have a picture, please draw a picture, okay? This is P, Q, R. Doesn't matter where P and R, but this Q has to be the middle, okay? When we say QS bisects it, all right, now how do you mark a bisection of an angle to show the world that they're equal? You can't put like a little tick mark. So what you do is you put a little arc. Everything with every angle with one arc like that is equal. Now you could do two. That's the same thing. 2, 3, 4. Usually you start out with 1, and then you have another pair of angles. You put 2 on those, another pair of angles, put 3 on those, or something like that to show that they're different but equal. All right, so we know that PQS is equal to 24 degrees, and they want to know what PQR is. They want to know what the whole thing is. Well, little plus little equals big. If this is 24, what does this have to be? It has to be 24. So 24 plus 24 is equal to the measure of PQR, and that is equal to 48. That's a really simple problem if you feel good about the word bisection and you understand little plus little equals big. All right, you got this. All right, so here's a perfect example of what you're going to run into. Why don't you give it a shot and solve for x only. We're not finding the, let's just solve for x. Save some time. If we have x, then we can plug it in, of course, to each one and find the angle measure. But why don't you give that a shot? Okay, we're back, and hopefully that worked out for you. So let's set it up. We know that little plus little is equal to big. The 143 is the big angle, ABC. So we set up 3x plus 23, 2x minus 40, 143. Man, I made a mistake on this last night, so I went back and checked my work. Didn't work, so I was like, whoa. So be careful. 3x, 2x, 5x. 23 minus 40 is negative 17. That's where I made my little mistake. We're going to add 17 to both sides. We're going to divide by 5. And this is what I asked you to find. If you wanted to find the measurements, then you just plug yourself in to the expression. 32 is our x, 64 minus 40, 24. Pretty cool. You got this. All right, I think this is your homework. There you go. Of course, I'm right there. Good luck today. Thanks.